Okay, on Thursday, we were looking at tables and we were identifying the type of function that it was, the x and y intercepts, if there were any, and then the minimum or maximum, if there was any. Okay, today we're going to be looking at the equations only. All right, no table, no graph, just looking at the equation to tell what the minimum or maximum is. All right, the minimum or maximum. All right, so to do that, we first need to remember how to identify an equation, what type of function it is from the equation. All right, so for linear, all right, our exponent, our greatest exponent is 1. There's only plus, minus, multiply, or divide, okay? There's no square root, there's no absolute value, nothing like that. And the x is, or your variable, is never in the denominator if it's in fraction form, okay? So you could have linear equations looking different ways, like standard form of a linear equation might look like this. Slope-intercept form might look like this. You might have point-slope form, which is like this. And you might have a horizontal line, which is like that, or a vertical line, which looks like that. Okay, so these are all linear. They all form straight lines. Okay, so if you see any equation, it doesn't have any exponents that can be seen. These are all invisible ones, right? So no exponents greater than 1, and the x is not in the denominator, then you're going to be linear. All right, now linear is a straight line, so we have no minimum or maximum, do we? So those are going to be the easy ones. All right. Okay, let's talk about exponential. How do we identify exponential equations? All right. The exponent is an x, your variable. Okay, so like f of x equals 3 to the x power. All right, quadratic is, you have an exponent is 2, no greater than. It's only 2. Okay. A cubic would be 3, all right? Exponent is 3. So exponent is 2. The largest exponent is 2. Now, quadratics can be in different forms. We have standard form, and you'll become real familiar with this. Ax plus by, plus bx plus c equals 0. This is standard form for a quadratic. And then we have vertex form, which is ax plus 1, and then you can have plus or minus, this is square, plus or minus a number, okay? So you might have f of x equals 3x squared plus 2x minus 5, You can have f of x equals x squared. It doesn't have to have all of that, but these all have x squares, right? So those are quadratic. You could have f of x equals x squared minus 2, or f of x equals 4 times x minus 1 squared plus 3. You say, well, the x isn't squared. Well, it will be when you simplify. Okay? This square goes with everything in here, so you're going to have an x squared in it. So this is vertex form. And we'll be dealing with that in just a minute. Then absolute value, those are easy to identify because they have absolute value bars in it. F of x equals absolute value of x plus 1, or absolute value of x. It's going to have the absolute value bars. Okay, so first we have to identify our equations before we can determine if they're determine the minimum maximum. All right. Okay, let's look at number 13 on the notes that I gave you. 4x plus 3y equals 24. All right, the exponent, greatest exponent on this is 1, right? The invisible 1. So that's going to be linear. So minimum and maximum is none. We don't have either one. It's a straight line when I graph it. So it doesn't have a top or a bottom. Okay. Look at number 14. 4x plus 3. So greatest exponent's 1. So again, linear. And there's no maximum or minimum. All right. Let's look at number 15. Erase some of this stuff. All right, so we have y equals 5x squared plus 1. All right, so our red flag is that square, variable squared, x squared. And it has to be your variable squared, okay? So that tells me that we have a quadratic. Okay? All right. So quadratics do a little bit different. To find our minimum and maximum. All right, let's talk a little bit about standard form for a quadratic. A while ago I said ax squared plus bx plus c equals 0. This is standard form for a quadratic. All right, a is just the coefficient. Coefficient means the number in front of. All right, so like 3x squared plus 2x plus 4. All right, b is the coefficient of x, and c is your constant, okay? It's just a number. It won't have a variable with it. All right, so if in this equation we don't have a bx, right? We don't have just an x to the first power. So b is 0, okay? Whenever you have an equation like that, your constant, your c, that's your y-intercept. All right, so when we have a quadratic in this form with no bx, Then C, that's our y-intercept. And in this case, our y-intercept, it says 4, so our y-intercept is 0, 4. If you ever have a quadratic without the center x, your y-intercept and your minimum maximum, your minimum or maximum are the same as your y-intercept. Okay? All right. The way you know if it's going to be graphing up or down. So if that's kind of hard to see, isn't it? If A is positive, then you're going to have a graph going up, so you're going to have a minimum. Okay? If A is negative, then your graph is going to be going down, and it's going to have a maximum because your top is there. All right, so going back to this equation, 5x squared plus 1. If 1 is my y-intercept and my A, 5 is positive, all right? So that means my graph looks like this. So my minimum, I'm going to have a minimum, is the same as my y-intercept. Okay? Okay, so today we're only going to look at a quadratic without the middle x, all right? Because it's easy to identify. Later on we'll look at it with the middle x. But I also want to look at it form. Okay, so vertex form. All right, for a quadratic, if you have, just say we got 2x plus 1 squared minus 4. All right, this number tells if it's facing up or down. All right, so if it's positive, you're going up. If it's negative, then your graph is facing down. Okay? All right. This number, the opposite of this number is the x coordinate in the vertex. All right, your vertex is the same thing as the minimum maximum. Okay, it's where that turn is. Okay. All right, and then this number is the y-coordinate of your vertex. Okay, you don't take the opposite of it. It's just flat out the y-coordinate. All right, so looking at this equation, it's a positive 2, So we know that it's going to be going up. So we're going to have a minimum, okay? And for the minimum, it will be at, we're going to take the opposite of this, so -1, that's our x coordinate. And then our y coordinate is the number on the outside, -4. Okay? A minimum at -1, -4. All right? Okay, let's try another one. And I know there's not one of these on your notes, okay? But I want to, when we get to absolute value, it does the exact same thing, all right? So let's say we've got -2 times x plus 3 squared plus 5. Okay? All right. So, first off, this number tells me if it's going up or down. It's negative, so it's going down. All right? So that means we're going to have, this is our vertex up here, so it's going to be a maximum. Okay? All right, our the point for that vertex, okay, this is also called a vertex. The point for that vertex is going to be the opposite of this. So it's going to be -3, and then it's going to be, this is going to be your y. Okay? So you're going to have a maximum at -3.5. What if, just say, what if I didn't have this? There was nothing out here. Okay, there was nothing out here at all. Your equation just ended. That was the end. There's nothing after it. Okay, if nothing is out there, nothing is 0. Okay? If nothing is here, then x would be 0. All right, so if I have, let's just say I have y equals x squared. Okay? It's understood that the leading coefficient there is 1. That's positive, so it's going to be going up, right? And there's nothing, it doesn't have any parentheses or anything, so it's going to be, the vertex is going to be at the origin. This is what they call a parent graph. It's kind of like it's at the origin, there's nothing added to it, you know, it's not going sideways or it's not going up and down. All right, like the parent graph for absolute value would be y equals absolute value of x. And it would also, it would be a positive v, and the origin would be the vertex. Okay? All right, and going on that, leading on, look at number 22. Y equals the absolute value of 2x minus 1. All right, so absolute value is going to work the exact same way as quadratic. The number on the outside, if there's nothing there, it's understood that it's 1. So this is going to be positive. So it's going to be a V going upward. All right. Inside here, there's nothing added. So my X is going to be 0. And then on the outside is my Y, and it's going to be -1. All right. So your vertex is at the bottom here. So we're going to have a minimum of 0, -1. Okay, let's look at number 23. 5 times the absolute value of x minus 3 plus 2. All right. So this number tells me that it's positive. So I have a V going up. So that means I'm going to have a minimum. All right? And a minimum in my vertex is a minimum, and it will be the opposite of the number outside of x. So it would be positive 3, and then the number outside the bars, 2. Okay. Okay, let's look at exponential. All right. Now exponential, you've got your base to the power of x. Okay? Your base to the power of x. All right. I'm trying to, I don't want to. All right. If our leading number is positive, okay? So if we start off with positive, and it's greater than 1, then it's going to be growth. Okay? If it's less than 1, then it's going to be decay. All right? Both of these are minimums. It's a crazy M. All right? Both of them are minimums. Okay? They both have a bottom. You say, well, when do we have a maximum? All right? If it's negative, if A is greater than 1, then what it does is, this is growth, right? Well, when you put the negative in front of it, then it flips over the x-axis and looks like that. Okay, so you'll have a maximum. All right, same thing if A is less than 1, then we have decay. But if you have negative A and that base there is less than 1, then you're going to flip it over and it's going to look like that. Okay, so whenever you have a negative in front of it, you're going to have a maximum approaching, and if it's a positive, it's going to be a minimum approaching. Okay, as far as growth and decay, if it's greater than 1, it's growth. If it's less than 1, it's decay. All right, when you do these negatives, these are called transformations. GRANS. And and we'll deal some more with transformations later. But I wanted you to see, I didn't want you to get confused about greater than 1 and less than 1, growth and decay. All right. Okay, so if we're looking at our notes, make sure I'm on the right page. All right, so if I have, let me just go to a new page. We have y equals 3 to the power of x minus 9. All right, so this number is positive. Okay, so that tells me that I'm going to have a minimum. Okay, my vertex is going to be, well, I don't have a vertex, but I'm going to have a minimum that is approaching, and the approaching is going to come from here, -9. Okay, so the number behind your base and your power of x, the number behind it is going to be what you're approaching. Okay. All right, look at number 20. We have f of x equals 0.5 x minus 2 plus 2. And you're like, oh wow, where did that come from, x minus 2? Don't worry about that right now. All right, all you're looking at is this number positive or negative? It's positive, so we're going to have a minimum. It is less than 1, and it's going to be decay, but it's going to be a minimum. You're going to have a graph that looks like that. Okay, so it's a minimum approaching, and what are we going to be approaching? We're approaching this. We're approaching 2. 21, y equals 5 to the x power. All right, so it's positive, so it's going to be a minimum, and it's going to be approaching. We don't have anything out here, so it's going to be approaching 0. Okay. All right, so the linear and the exponential are pretty simple, straightforward. It's positive, it's minimum. If it's a negative, it's maximal. All right. Let me do an example of a negative. If I have y equals negative 2x plus 1, then it would be a maximum approaching 1. Okay. All right. The quadratic and the absolute value, they work the exact same way. It's whatever's in the parentheses or inside the bars, like x plus 1 or x plus 1. Let's do them. This is absolute value, and this is quadratic vertex form. They would have the exact same thing. Your vertex would be the opposite, -1, and this, -3. And since it's positive, it's going upward, so you'd have a minimum. Okay, so absolute value and quadratic work the exact same way. It's just they look a little different. Okay. All right, you just need to do the back of yesterday's homework. All right. All right. Y'all have a good weekend and be ready for Monday morning. I'll see you then. Bye.